3, 2, 1. Hello again, and welcome back to the second episode of Electrofly's Garage. So what we're doing today is we are getting this puppy back airborne again. Last episode we made the sacrificial 3D printed landing gear setup, and this time we're putting the front back on. We are making some adjustments, and then we are actually going to put the wings back on and see if we can get some flight today. Now, in the meantime, let's talk a little bit about why we're doing this. So, I'm making these videos mainly for myself in the future, but the other audience is also anybody else that wants inspiration for their own future projects, or if they want some extra technical expertise. I want to help you all out on the way. I am by no means an expert. This is my amateur first try at this, but I wanted to share with you any lessons I learned along the way, like measure twice, cut once, those sorts of things. So we have a lot of those. It's going to be a little bit of a longer video today because I took a lot of footage of the process, and I hope that you find it interesting. See you. Now the purpose of today's activity is to recreate this. So this was my attempt at creating a sacrificial landing gear connector that goes on here. However, I was stress testing it right after the recording of last video, and unfortunately it broke. It did what it was supposed to do, which I'm proud of it for doing that, but I also probably should have thought through my actions before doing them. That said, I was rather proud of it for doing its job first of all, and also withstanding a fair amount of force before it actually broke. So now what we're doing today is I printed a couple more of them. I printed them from a different direction this time, and we'll see how it goes. I printed 2 of them. It took about 4 hours to print 2 of these. And we need to start by taking off the scaffolding. So this helps the print. If you print from a direction where stuff is hanging out over empty air, you have to put scaffolding in there. The print, they have what's called a slicer, which helps you create scaffolding and other things. It tells the 3D printer what to do. So our next step is we take our very handy set of pliers and we begin to cut off some of this wavy looking scaffolding on the outside. It's kind of a destructive process. You are essentially tearing things off of the print, but it is necessary for the new print to work properly. Alright, so this is what the new part looks like with all of the scaffolding removed. Here is the old part. As you see here, I made one more change to this part since last time. I made it so that the tab extends all the way across, and I also put a little radius there. You may know it as a fillet to improve strength. The other thing is that I changed the direction of the print. If you look carefully, you can see that the print was actually done this direction this time, from bottom to top that direction. In this print, I printed it from bottom to top this direction. So side to side, this way, and this way. The reason why I made the change is that this way requires less scaffolding, and it should also hopefully be stronger. The way that 3D printing works is that you have a concept called delamination. Each layer is like a cake on top of the old one, and it kind of sticks together. But even after it sticks together, those layers are a little bit weak. They're easy to come apart. If I tear this direction, it's going to be a little bit weaker than if I try to go this way, or if I try to punch it, or if I do anything like that. So we want to make sure that the forces that are going on it do not go in this direction. We don't have tension trying to pull apart these little layers on the cake. So I decided to print it this way because this will just go on here, and the idea is we will ideally not have any sort of force this direction, since the force exerted on it, if we attach it to the wheels right here, will be mainly torque going like that. If you can imagine landing, you're going to have the wheels kind of going every time you land. Apologies for the sound effects. So here comes the fun part of this activity, which is sticking it on. Yay! Okay, so let's try it. a bit of a comment here. You want to make sure that when you're making things out of foam board that it's exactly perpendicular when you're putting it all together. As you can see there, it's a little ripped when I tried putting in the previous iteration of this 3D printed part, because while the 3D printed parts were exactly 90 degrees and exactly to what I wanted them to be, the foam board is not exactly perfect. So what we're going to see now is if this thing will go on without causing a huge fuss. Alright, status update. So we did get the part on, but as you can see I kind of had to force it on, which was not too great for the plain fuselage. But these things happen. I feel like that one meme that's like, we've won, but at what cost? That's okay. It's on there, and now I can move on to the next step. Another interesting thing that I'm going to talk to you about while I apply the landing gear is the screws necessary to keep the landing gear in place. So the original landing gear we did not even screw in. It was just hot glued with sticks, or popsicle sticks to be precise, to the front fuselage. And this worked okay while we were building it, but as soon as we launched it, the thing broke apart rather quickly. So now we have a landing gear set that is screwed in to the fuselage body, or in this case the sacrificial 3D printed part, and hopefully this will be quite a bit stronger. It has held up quite well in the past. The screws in fact were so strong that instead of the landing gear itself breaking, it tore off the entirety. Hello. Yeah, the shish kebab skewers will cause the foam board to actually get cut and stretch out as forces are applied to it, such as during a crash landing. So instead, what we have here are 3D printed fillers that we can put through these holes in the forward section, and from here we can then put a shish kebab skewer through them without worrying too much about how it's going to stretch out, because ideally we're going to hot glue all around here, make a nice fillet, and that will keep it exactly in place each time. So now we have the reinforcements glued on. This is what it looks like from the interior side. Then we have the left side. And the next step is to actually attach these onto here. So the way it's going to kind of look is something like that. And then we're going to run a couple of rods through them on both sides. And hopefully this will be enough to keep it in place during flight and during pretty much anything. And last but not least is the motor mount. So there are a couple of restraints on where this motor is actually placed. So first of all, we want to make sure that when the plane is level, that doesn't mean all landing gear on the ground. That means when the plane has just started to take off, or when it's right about to land, when the wings are level and the body is level, then we want to make sure that the propeller does not scrape the ground. So right here, I actually have it propped up on my tripod to make sure it's level, and we can see that it just barely stays off the ground, so that's good. And the other thing is we want to make sure that the propeller is actually facing forward, because if it's facing down, or angled down more specifically, it's going to cause problems for lift. So we want to make sure it's either exactly level or angled slightly upward. And that's why I had to take extra precaution to make sure that this propeller here was level with the rest of the aircraft. Alright, so my 3D printed items just finished. I'm going to see if I can hold the camera with one hand and take them off for you with the other. So the thing with 3D printed is that they will stick to the print bed if done correctly, and you need to figure out how to get them back off. I usually use pliers because otherwise it will not come off. These are some of the more difficult ones to extract. Yarr, I could not get that off. Okay. Well, you see the idea though. Usually you can get them off by holding the printer down with one hand and using the pliers for the other. There are probably much more elegant ways. I've heard some people have taken the entire print bed off and then kind of bent it backwards. That's another option. Usually if you're using things like ABS, which is a slightly tougher print material, I'm using PLA right now, but if you're using ABS, usually you can just pry it off manually since it doesn't stick to the print bed as well. But this PLA is sticking really well, so I'll have to pry it off with my pliers and some brute force. That's starting to look like an honest-to-goodness plane. Now the next step is putting the wing back on, and there is actually one more section that needs to be put on. However, this one's pretty simple. The way it works is it goes over on top like this and serves as a roof. Pretty simple, and we're just going to affix it with rubber bands. In fact, I can probably show you. Let's see, now I'm going to need my other hand. Maybe not. Yeah, I'm going to cut this. I did a little bit of work off camera here. I'm just putting the electronics back in. So this is the receiver module here, and each one of those little pins consists of 3 pins that connect to a servo. So servo 2 connects forward, actually no, servo 3, channel 3 connects forward to the motor. Channel 2 connects back to what I believe is the elevator, and then 4 is rudder. And what we're about to do is put back channels 1 and 7, which I have designated in the programmed transmitter to be the ailerons. One is the left aileron, one is the right aileron. The reason why I have them as 2 separate ailerons is so that we can adjust one of them automatically within the programming without having to adjust the physical part of the apparatus here, because fixing those wires is a bit of a pain. And here we go. Elevator, rudder, aileron, motor. We're good to go. Okay. So here's what the plane looks like in full constructed form, ready to fly. So we have some rubber bands going over the top here. This is the top part of the fuselage that I mentioned earlier. And we also have 4 rubber bands on each side going across the top of the plane. We want to make sure that these lines align, as do those, to make sure that the wing is balanced. And we're ready to fly.